f of x is equal to square root of x square minus 3x plus 2. X square minus 3x plus 2 greater than or equal to 0. This implies x minus 1 into x minus 2 greater than or equal to 0. Coefficient of x square is positive, expression is positive. When both are having the same sign, x cannot lie between these two values 1 and 2. Therefore, x should be less than or equal to 1 and x should be greater than or equal to 2. Therefore, the domain f can be written as minus infinity to 1 union 2 to infinity, or from the real numbers set, you can remove all the values between 1 and 2. Next one, f of x is equal to square root of 2 plus x plus square root of 2 minus x by x. 2 plus x greater than or equal to 0. This implies x is greater than or equal to minus 2. 2 minus x greater than or equal to 0. This implies x is less than or equal to 2. And x is not equal to 0. So you can take all the values between minus 2 and 2 and remove 0. Therefore, from the closed interval minus 2 to 2, delete the number 0. This is domain. Or domain f is equal to minus 2 to 0 union 0 to 2. Now f of x is equal to log of x square minus 4x plus 3. X square minus 4x plus 3 should be greater than 0. This implies x minus 1 into x minus 3 greater than 0. Coefficient of x square is positive, expression is positive. X cannot lie between 1 and 3. So x should be less than 1, x should be greater than 3. 1 by cube root of x minus 2 into log 10 to the base 4 minus x. X minus 2 is inside the cube root. Inside value cube root, it may be positive or negative. Because it is in the denominator, it cannot be 0. Therefore, the first condition is x minus 2 not equal to 0. That means x is not equal to 2. The second one, 4 minus x, it is in the base of the logarithm. Therefore, 4 minus x is not equal to 1 and x is not equal to 3. Because the base should be positive and it should not be equal to 1. Also, the base is positive means 4 minus x is greater than 0. This implies x is less than 4. So, x is less than 4 and x is not equal to 2 and x equal to 3. Therefore, x not equal to 4 means it is minus infinity to 4. And 2 and 3 should not be there. Therefore, these two numbers are to be eliminated from this. Therefore, domain f is equal to minus infinity to 4 minus the two elements 2, 3. Find the domain of the definition of the function y of x given by 2 power x plus 2 power y equal to 2. Find the domain of the function y of x given by 2 power x plus 2 power y is equal to 2. Now 2 power x is less than 2 implies log of 2 power x to the base 2 is less than log 2 base 2. This implies log of 2 power x to the base 2 is less than 1. This implies 2 power x is less than 2. This implies 2 power x is less than 2 power 1. So finally this implies x is less than 1. Cos x plus e power root x. For cos x, domain is R. For root x, domain is R. So therefore, x should be greater than or equal to 0. Because for e power x, the domain is capital R, therefore root x belongs to capital R, automatically x must be positive. And domain of cos x is R, and the values which are common to both are from 0 to infinity, therefore the domain f is equal to 0 to infinity. So for cos x domain is R, for root x domain is R, and x is inside the root, it should be greater than or equal to 0 because root x is real number. So therefore, it should satisfy, x value should satisfy this. That means x must belong to capital R and x must be greater than or equal to 0. Therefore, put together, we can come to the conclusion that the domain is from 0 to infinity. And f of x is equal to secant x minus tan x. We very well know that for secant x, domain is R minus x such that x is equal to odd multiple of pi by 2. N belongs to Z. And for tan x also, domain is equal to capital R minus x such that x is equal to 2n plus 1 into pi by 2. N belongs to Z. So this is the domain of secant x, this is the domain of tan x, both are common. So therefore the common domain for both is the domain of f is capital R minus x such that x is equal to 2n plus 1 into pi by 2, n belongs to Z. Next one, fx is equal to cube root of x into cot x. Cube root of x, this is defined for all real values of x. So for cube root x, the domain is R, and for cot x, it is R minus x such that x is equal to n pi. So for cube root x, domain is R. For cot x, domain is R minus x such that x is equal to n pi, n belongs to Z. Therefore, the common domain for both, which is the domain of f, is nothing but R minus x such that x is equal to n pi, n belongs to Z. Next one is f of x is equal to sin x by x minus 2. For sin x, domain is capital R. For 1 by x minus 2, the domain is R minus 2, since x minus 2 is not equal to 0. Therefore, the common domain which satisfies both is R minus 2. Therefore, domain F is equal to capital R minus 2. Now f of x is equal to x square minus x minus 1 by 2x square plus 4x plus 5. This is in the form of x by gx, and x square minus x minus 1 is defined for all real numbers, and 2x square plus 4x plus 5 is not 0 for any real value. Therefore, this domain is R, this is R. Therefore, the domain F is capital R. Since 2x square plus 4x plus 5 is not equal to 0 for every x belongs to R. Now f of x equal to log of x minus 2 by root 3 minus x. And this x minus 2 should be greater than 0. This implies x is greater than 2. 3 minus x is greater than 0. This implies x is less than 3. Therefore, x should be greater than 2 and less than 3. Therefore, domain F is 2, 3. Next, f of x is equal to 2 sine inverse x plus 3 cos inverse x. For sine inverse x, domain is minus 1, 1. For cos inverse x, domain is minus 1, 1. So, we know that the domain of sine inverse x is minus 1, 1, and the domain of cos inverse x is minus 1, 1, and the common interval for both is minus 1, 1 only. Therefore, domain F is equal to minus 1, 1. This is close bracket. F of x equal to 3 tan inverse x minus 4 cot inverse x. Domain of tan inverse x is capital R. Domain of cot inverse x is also capital R. Therefore, when the domain of tan inverse x is capital R and the domain of cot inverse x is capital R, the common domain is capital R. Therefore, domain F is equal to capital R. Now f of x is equal to sine inverse x plus secant inverse x. For sine inverse x, the domain is minus 1, 1. For secant inverse x, domain is minus infinity to minus 1 union 1 to infinity. So, The common domain is the domain of f. Therefore, it is very clear that domain of f is minus 1, 1, only these two values. Now, fx is equal to sine inverse step x. For sine inverse step x, the domain is minus 1, 1. So, domain f is equal to x such that minus 1 is less than or equal to step x is less than or equal to 1. That is equal to x, that is equal to x such that minus 1 is less than or equal to x is less than 2. Therefore, so for sine inverse root x, the domain is minus 1 and 1. Therefore, this root x should be in between minus 1 and 1. And all the integral values between minus 1 and 1 or minus 1, 0, 1. Therefore, step x will be minus 1 or 0 or 1. That means we have to accept all the values of between minus 1 and 2, where step x gives the integral values. Therefore, the domain is domain f is equal to minus 1, 2. F of x is equal to sine inverse 4x. The domain of sine inverse of 4x is minus 1 to 1. That means minus 1 is less than or equal to 4x is less than or equal to 1. This implies minus 1 by 4 is less than or equal to x is less than or equal to 1 by 4. Therefore, the domain is minus 1 by 4, 1 by 4, closed interval. So, 4x lies between minus 1 and 1. If we divide by 4, minus 1 by 4 less than or equal to x less than or equal to 1 by 4. Therefore, the values of x lies in between minus 1 and 1 by 4 and 1 by 4. Therefore, the domain of f is minus 1 by 4, 1 by 4. Now, f of x is equal to cos inverse x by 3. For cos inverse x by 3 also, we know that minus 1 is less than or equal to x is less than or x by 3 is less than or equal to 1. That is minus 3 is less than or equal to x is less than or equal to 3. Therefore, domain f is equal to minus 3, 3. So, for cos inverse x by 3 lies in between minus 1 and 1. So, therefore, x lies between minus 3 and 3. Therefore, the domain of the given function is minus 3, 3. F of x equal to tan inverse 2x. Domain of tan inverse 2x is capital R. Therefore, 2x belongs to R implies x belongs to R. Therefore, domain f is equal to capital R. So, for tan inverse 2x, the domain is capital R. That means 2x belongs to capital R and hence x belongs to capital R. Therefore, the domain f is R. f of x is equal to log of tan inverse x. Log of something should always be positive. Therefore, the tan inverse x domain of log tan inverse x is 0 to infinity, because log of something should always be positive. That means log of something should be greater than 0. So therefore, domain of log tan inverse x is 0 to infinity. And if tan inverse x is greater than 0, implies x is greater than 0. Therefore, the domain f is 0 to infinity. F of x is equal to cos inverse root 2x. Since 2x is inside the square root, 2x must be greater than or equal to 0. That means x is greater than or equal to 0. And since the domain of cos inverse is minus 1 less than or equal to root 2x equal to 1. So if we square 2x is less than or equal to 1, therefore x is less than or equal to 1 by 2. Here x is greater than or equal to 0 and here x is less than or equal to 1 by 2. Therefore, domain f is equal to 0, 1 by 2. Sine inverse x minus 3 by 2 minus log of 4 minus x to the base 10. This is f of x. Now for sine inverse of x minus 3 by 2, minus 1 is less than or equal to x minus 3 by 2 is less than or equal to 1. That means minus 2 is less than or equal to x minus 3 less than or equal to 2. If we add 3, 1 less than or equal to x less than or equal to 5. And here 4 minus x should be greater than 0. This implies x is less than 4. So therefore, here 1 is less than or equal to x is less than or equal to 5. And here x is less than 4. So suppose if 1 is here and 5 is here, according to this we can take values from here to here, and according to this less than 4. Therefore, domain f is equal to 1, 4.